Hi grade 8s, it's assignment number 17 and I predict you're going to hate this video. Why? Well, I think it's going to end up being pretty long. Sorry. There's a dryer going on in the background, so you've got that to deal with. Listen to it. Plus, this is going to be the hardest lesson of the whole year probably. This is really hard. So brace yourself. Do the best you can. If it's too much, you know what? It's going to be okay. But let's give it an honest try. So with no further ado, let's jump right into it. We're doing surface area still, but we got more difficult questions. So remember, surface area is like if you were to paint the outside of something, how much paint would you need? It's the area of all the outside faces. So we need to get the area of this face and this face and the bottom face and this face. Now you can see we kind of have two shapes in this one. We have a rectangular prism on the bottom and a triangular, well, it's actually a pyramid, isn't it? A pyramid on top. So let's think about this. Your initial thought is probably, well, I'm going to get the surface area of the whole rectangular prism. I'm going to get the surface area of the whole pyramid, and I'm going to add them together. You're close, but you see what the problem is with that? If I was going to paint this, there's certain parts of the rectangular prism I wouldn't be painting. What wouldn't I be able to paint the way it is right now? If I just took a paintbrush and started painting this, I would not be able to paint the top, right? This right here, I wouldn't be able to paint that in the rectangular prism. And similarly, if I was going to try to paint the pyramid, I wouldn't be able to paint the bottom, which ends up being the same area. It wouldn't be able to paint the bottom of the pyramid. So what we're going to have to do here is get the surface area of the rectangular prism. I'm just going to draw a little rectangular prism. But no top, but not the top. And then we're going to add to that the surface area of the pyramid. That's not a great pyramid, but not the bottom. That's what we're going to have to do. I hope that makes sense. So let's start with the surface area of the rectangular prism on the bottom here. So how many faces are we worried about then? Usually with a rectangular prism we're worried about 6, but in this case we're only worried about 5 because we're not worried about the top, remember. So we're worried about the bottom. So we need to get the area of the bottom. Now, is there any other, it's a rectangle, isn't it? Yeah, they're all rectangles down here. What are the dimensions of the bottom? 4 by 4. So to get the area of the bottom, we have to go length times width, which is 4 times 4, so you get 16. Now, is there any other rectangles the same size as that? I don't think so. All the other ones have the same dimension, so the other 4 rectangles are all the same. They have the base is 4, the base is 4, the base is 4, the base is 4, and the height is 6, height is 6. So all the other ones are 4 by 6. So the area of the sides, again, these are rectangles, so it's length times width. So if you're not sure what I'm talking about, I'm talking like one of these. The dimensions are 4 by 6. So we can go 4 times 6, which is 24. But again, how many of those are there? There's actually 4 of them. All the way around, it's 4 by 6. This is 4 by 6. This is 4 by 6. And this is 4 by 6. So all you have to do then, once you got the area of one of the faces, is to multiply it by 4. And if you do that, you're going to get 96. Okay, we're done with the rectangular prism. Now what we need to do is to get the area of all the faces of the pyramid. Well, again, look, all those all those triangles, because this pyramid's made up of 4 triangles, they're all the same. It has a base of 4 in this triangle, a base of 4 in this triangle, a base of 4 in this triangle, a base of 4 of this triangle. They're all the same, so this isn't going to take very long. So this was for the rectangular prism, and now we're doing the pyramid. And to get the area of the sides, they're triangles, so you're going to go base times height divided by 2. The base, we just said, all the triangles is 4. So 4 times, what's the height of the triangle? That would be this distance. Well, wait a minute, they give it to us over here. The height is 5. So 4 times 5 divided by 2. That's 20 divided by 2, which is 10. Again, how many of these triangles make up this pyramid? There's 4 of them, so we need to multiply by 4 and get 40. Now, what about the bottom of the pyramid? Do we do that? No. Remember, we can't get to that with our paintbrush. So that's not exposed. That's not something we can paint. That's not part of the surface area. So we're done. All we have to do now is take this number, and this number, add them together, and we'll have our total surface area. So the total surface area is 16 plus 96 plus 40, and that equals 152, and we're talking about centimeters. It's surface area, so it's still squared. Done. Not that bad, right? Yeah, that was the easy one. Okay, let's go on to these ones. Okay, we're going to do 3 total. All right, so we want the surface area of this. Okay, so we've got 2 cubes sitting one on top of each other. So again, it looks like what we want to do, maybe, kind of, sort of, is get the surface area of the bottom, the surface area of the top, and add them together. And that'd be great, except for one thing. There's overlap here, right? Because one's sitting on top of the other, you can't paint the bottom of the small cube, and you can't paint all of the top of the big cube. But it's going to be really hard for us to get the area of like this bit here. How are we going to do that? That's definitely something we can paint. So here's the stroke of genius you need to realize about questions like this. If I was to paint all the top of this one, but also paint all this part around it here, what did I just paint? What is that equal to? What amount is that equal to? If you're having troubles figuring out what I mean, imagine looking straight up above, like a bird looking down on this, and it can't tell what's closer and what's further apart. What would it actually look like you'd painted if you'd painted all this and all of this? It would actually look like you'd painted the same amount as the bottom of this cube. Do you see that? The bottom of this cube is exactly the same amount as this plus this that goes all the way around the outside. So what does that mean? Well, what that means is we need to get, obviously in the big cube, we need to get all the sides, the one at the front, the right side, the back, and the left side. We also need to get the bottom of the big cube. And in a sense, we also need to get the top of the big cube, because that'll take care of this purple bit I've painted here. So we want to get the surface area of the whole big cube, and we need to add to it, what will we still have to get in the small cube? Well, we won't have to get the bottom, because that's not paintable, right? That's covered up. We won't have to get the top, because we already dealt with that when we did the whole big cube. So we'll just have to get the 4 sides. So the surface area of the sides of the small cube. Now, if you can see that, the rest of the question isn't horribly difficult. The problem is figuring out this, what I just did. That's what makes these questions so hard, is to figure out what exactly do I need to figure out in this question. What exactly do I have to calculate? The actual calculations aren't too bad. Okay, so let's start by getting the surface area of the big one. I'll put surface area of big. Well, the good thing that's a cube is all 6 faces are exactly the same. So let's get the area of any face. I'll get the front, the area of the front. Now, it's a square, so you could go side squared, if you like doing side squared, but I imagine most of you do length times width. So I'll go length times width. So let's take a look. We're talking about this face right here. What are the dimensions? 12 by 12. It's a square, so they're the same, 12 by 12. So we go 12 times 12, and we get 144. How many faces are the same in the cube? They're all the same. All 6 faces are the same, so we're going to multiply that by 6. And we get 864. Okay, great. So we have now figured out the surface area of the entire bottom cube, including this purple rim here, and we've also figured out this purple one here, right? The top here. Because again, if I was to remove the small cube, let's say, if I was to lift the small cube off here after I'd painted the whole thing, there'd be this empty, non-painted square in the middle here, wouldn't there? Well, you know what would fill that in perfectly? This purple bit right here. So by finding the surface area of the whole big cube, we've already effectively found the surface area of that. That's the hardest thing. I mean, usually it takes me 2 or 3 lessons to try to really get most people to understand that. Here I'm trying to do it in what, a 15, 16 minute video? So good luck, I guess. And definitely reach out and ask me questions. I'm here for you. All right, now we just need to get the surface area of the sides in the small one. Well, that's not bad because, again, this is a cube. So all we need to do is get the area of one face. I'll get this one, I guess. So the area of the front of the small one. It's a square, so side squared or length times width. How much is this? Well, it's the same as this. It's 8 by 8. So 8 times 8 is 64. Now remember, we're not doing all of them. We're not doing the bottom because you can't paint it. You're not doing the top because we've already done it. You're only doing the 4 faces here. So we're going to multiply by 4 and you get 256. And that's it. There's no other faces to do. We just have to add together the 864 and the 256 and we'll be done. So total surface area equals 864 plus 256, which equals 1,120, and we're talking about inches, so inches squared. Okay, still with me? Here comes the hardest of all. I don't know, you might not find this one the hardest of all. Actually, I'd say the hardest thing of all is figuring out this idea that the purple piece here fills in the remaining gap of the big cube there. But this one's very hard too. So what we have here is a cube again, all these cubes, and then we've hollowed out, we've dug out of it a cylindrical shape. So this is literally open here. You could stick your arm through the cylinder part. Okay, it's a cube with a cutout in the middle of it. So let's think about this. What do we need to find? Well, the part that most people don't have problems with is you need to find the total surface area of the cube, and then they say you need to minus the surface area of the cylinder. But it's not exactly correct. Let's think about this for a second. I like getting the surface area of the cube. That's good. Now, if I was to, let's imagine you'd had a whole cube and you painted the whole thing, and then you hollowed out this cylinder shape in the middle there. How much have you lost from the original shape? You've lost one circle here, and you've lost one circle there. So it's actually not the whole cylinder that you'd have to subtract. It's just the 2 circles. So you're going to subtract the 2 circles of the cylinder. Okay, if you got that, that's very good. Good for you. Now, if you can get this next step, even better. Because here's the other thing. When you hollow out that cylinder, is there any new faces that you could paint? Yes, there is. What could you now paint now that you've hollowed that out? You could reach your arm in here and paint all inside the cylinder here. All inside this cube where the cylinder shape is, you could paint in there. You can't paint the circles. There's no wood or metal or whatever this is. It's just air. But you could definitely reach in and paint the inside of the cube in this cylinder shape. So that's a new face that can be painted. It's a new face that's exposed. So you need to add on, what did we call that? We called that the soup label or the toilet paper roll or the lateral area is really what it's called. We need to add on the soup label of the cylinder. So this is really hard to understand, isn't it? You started with the whole cube, so that's why you're going to get the surface area of the whole cube. Then you hollow out this cylinder shape. Well, that means you no longer have paint on this circle and you no longer have paint on that circle. That's why we took away the 2 circles. But wait a minute, when you hollowed that out, you could now reach in with your paintbrush and paint all inside there. So that's a new face that's part of your surface area. So you need to add on that soup label there. All right, let's give this a try. So first is the surface area of the cube. Gosh, love these cubes because they're so fast. All we have to do is get the area of one face. So I'll get the front and then multiply by the number of faces. So the area of the front, well, the area of the front is this right here. It's a square. So again, you could do side squared or you could do length times width. The dimensions are 10 by 10, which equals 100. And how many faces are there that we're worried about? We're worried about the whole cube. And on the whole cube, there's 6 faces, front, back, top, bottom, left, right. So we have to multiply that by 6, and we get 600. All right, now we're going to take away the 2 circles. So let's get the, I'll put 2 circles, and we're going to get the area of just one of the circle. So what's the area of a circle? Pi times the radius squared. So pi times, what's the radius? I think this 5 is supposed to be the whole way, unfortunately. because that means that our radius is half of 5, and it's 2.5. Ew, decimal. So remember, you're going to square first. 2.5 squared is 6.25, and then you're going to multiply by pi. You could leave it like that, but I'm going to actually multiply it by the 3.14, or use my pi button. And I get 19.6 when I do that. But wait a minute, that's just one of the circles. I just found one of the circles. I need 2, so I better multiply that by 2 to get both circles. And I get 39.2. So now we need to figure out the area of the soup label, and we need to add that on, right? So soup label. Area equals. Uh-oh. How do we get the area of the soup label? Okay, I need to remind you of something here. Do you remember when we did the surface area of a cylinder, what the formula was? The formula was, so I'm going to write down here, 2 pi r squared plus 2 pi rh. And one thing I told you at the time, which didn't seem so important then, but seems really important now, is this referred to the circles. So here, when we found the two circles, this is what we did. We did our pi r squared and multiplied it by 2. We did 2 pi r squared, basically. I should have done it like that, I suppose. But I just wanted you to understand the circle, and I did it this way. Anyway, so we had to take that amount away, and then this is your soup label right there. So now we're going to add on the 2 pi rh. That's the area of the soup label right there. It's actually called the lateral area. So that's what we're going to do, 2 pi rh. So what we got here? We got 2, we got pi, we already did the radius, it's 2.5, and the height of this cylinder, the height is from here to here. How much is that distance? Well, it's exactly all the way across the cube, so it's 10. So we have to multiply it by 10. If you do that, you're going to get 50 pi. You get 157.1. So now we have all our numbers, but be careful. Remember, we're taking this one, we're subtracting this one, and we're also adding this one. So I could do the adding part first. Total surface area. What I'm going to do is I'm going to take 600, I'm going to add the 157.1, and I'm going to subtract the 39.2. And that gives me 717.9, and it's centimeters squared. All right, I get it if your head's spinning a little bit. These are really hard. Okay, do the best you can. Give it a shot. Reach out to me and I can help you with specific questions. I'm only going to give you three questions. They're on a worksheet. It's a worksheet. I'll post it again, but it's the worksheet you did a couple classes ago when you did some questions on surface area of cubes and rectangular prisms and triangular prisms. It was assignment 15. So if you want, you can just use that again, or I'll post the exact same worksheet again. You're going to do C, D, and F. If you like them, because they are kind of challenging and can be fun, you're welcome to do a few of the other ones in number 1 as well, and impress me with any of the ones you can get. They're really hard. So this is assignment 17. It's due Friday, June 12th at 3 p.m. That'll leave us with 2 more assignments. One's number 18, which is the review. I already have that in Teams. And then number 19 will be quiz number 4. And then that'll be it. I guess number 20 will be your project. I don't know if I ever put a spot for you to hand in your project. Some of you emailed it to me, which is fine. That's great. You don't have to also do it, put it on Teams. But I'll make a number 20 because I love round numbers. I'll make a number 20, which is for your project. And then that's it, people. So I might make one more video to say goodbye, but this is the goodbye for this video. And good luck, and let me know when you need help. Bye.